recording, Josh. Be quiet.
If a line is tangent to a circle, then the line is perpendicular to the radius drawn to that point of tangency. This theorem says basically that we will not see this. We will only be told that M is tangent to circle O at point T. Well, that means that we can conclude that we have a 90-degree angle right there. And thus, we can draw a line from O to the end point of that segment or somewhere and use right triangle information to find any missing pieces. Okay?
Like to find the radius?
We could find the radius, we could find whatever. Whatever we need to find. All right?
Tight, yeah.
Our second one, we also drew this picture yesterday. If you recall, I had a circle with these lines and I had a little ruler up there where we measured from the outside point to the point of tangency, and they were both 3. The second theorem says that the tangents to a circle from a given point, and I don't have the word given, but please put that in your notes. The tangents to a circle from a given point are congruent. So that means when you see this picture, automatically you know that those two things are equal to each other. So that's one of those, you know, when you're doing your homework and you're going, huh? It's just one of those things. It's like, oh yeah, these are equal to each other.
Wait, what? What's
Two tangents.
The two tangents, the segment from this point of tangency to this point outside the circle, and the one at the bottom.
Oh, just from the 2 points?
From the points, not the extra stuff. All right, and then this is the inverse of the first theorem. The first theorem said if the line is tangent, then we know it's perpendicular. This one says if it's perpendicular to the radius, then we know it's tangent, and we know what the point of tangency is. So if we're given this picture, and there is a little red box indicating that it's a perpendicular, those two lines are perpendicular to each other, then we can conclude that line L is tangent to circle O at point R. So it's just some little automatics there. When you're doing your homework and you see that picture, you automatically know it because of these theorems.
Awesome.
And again, it allows you to draw right triangles and use your right triangle theorems and information to find anything you need to find.
How do you label a circle? I mean, like, write its name? A circle.
Middle thing.
It's a circle, and you put the dot in the center because it's signifying that the center is O. So this would be circle O.
That'd be confusing. Circle
Okay.
O.
So if you see that. Okay, yesterday we drew circumscribed circles or inscribed circles where the polygons were on the inside of the circles. Today, the circles are in the inside of the polygons. And this is simply two different ways to say the same thing. For instance, if Josh and his dad were standing next to each other and you had never met them before, I could say, Chris, this is Mr. Myers' son. Or I could say, Chris, this is Josh's father. I've said it two different ways, but I've explained the relationship the same, right?
C.
Okay. Now, yesterday we said for a polygon to be inscribed in a circle, all three vertices, or all of its vertices, had to be touching the circle. What do you notice about these circles when they're inside the polygon?
Touches it, however many points they have sides.
The circle must touch every side at a point. This is a three-sided figure here, and the circle is touching it on all three sides.
Is it always going to do that?
Yes. This is a four-sided figure, and it is tangent to all four sides. If one of the sides is not being touched by the circle, you cannot say it has been circumscribed or inscribed.
What if you have a trapezoid and the top is like way up here and the bottom is here and the sides are real slender? How's it gonna?
Then you probably can't put a circle in it and make it touch all of them. You wouldn't be able to.
You put a Google.
Is it like?
Okay.
Is this just
Why
for
do you come
circles?
up with this?
Yes. Okay. This is a picture of what common internal tangents would look like. You have two circles. Notice there is an imaginary broken line joining the centers of those two circles. Both of them are tangent. Let's call this line K. Both of them are tangent to line K. The first circle is tangent to it here. The second circle is tangent to it here. We say it's a common tangent because they both are common to the same, tangent to the same line. It is internally tangent because the line passes between the centers of the circle.
So if it passed on the outside.
Exactly, and I'm going to show you a picture of that as soon as y'all are finished with this, okay? So this is a common internal tangent. This next picture shows you a common external tangent. We could call this line M. It is tangent to both circles, but it does not pass between their centers.
What does this have to do with like solving properties and stuff?
What does it have to do? We will be able to use right triangles, parallelograms, trapezoids to find measures of whatever we need to find. That's what it has to do with. This is a picture of two circles that are externally tangent to each other. If this is circle O and this is circle Q, circle O and Q are externally tangent. They both share a single point, yet they are not inside of each other. They also have a common, what is line L?
Tangent.
What kind? External, internal?
Internal.
They have a common internal tangent, line
Why?
L. Because circle O is tangent to line L, circle Q is tangent to line L, and line L passes between the centers of those two circles. You've been studying your recitation, you have to be paying attention.
Yeah.
It's pretty
Or
easy.
not to be that.
Yeah, well,
It's
I
okay, yeah,
completely
let's-
forgot about it for this period.
So do you have
This is a picture of two circles that are internally tangent to each other. The circle themselves, one is inside the other, and they touch at a common point, so they are internally tangent. Now the line drawn here is a common, what?
external?
External tangent to the circles. So all this terminology, you have to know what we're asking about. You can't just look at the picture and make a guess. You have to know what I'm asking. If I said, what is line S to the two circles, you would say a common external tangent. If I said, what's the relationship between the two circles, you would say they are internally tangent.
The line is
So
external.
that's an
Right.
external common.
The line is externally tangent to both